Hey everyone, my name is Jenny Mann. I'm a solutions architect at UiPath. If you've done any UiPath development, you would know that selectors can be a monster sometimes. While it's cool to be able to use it to do UI automations, sometimes they can give you a lot of trouble. Today, we're going to go over many different ways to fine-tune a selector and manage difficult situations. We'll explore some of the most common ways to repair selectors in order to make sure that the correct UI elements are identified in as many automation scenarios as possible. Let's open Studio and create a new project. First, let's copy the resources folder, which contains 3 text documents, to our project folder. In this scenario, we will create a workflow that removes the double spaces in a Notepad document using UI interaction activities, which generates selectors, as we already know. Afterwards, we'll fine-tune the selectors that identify the application in such a way as to make our workflow applicable to multiple Notepad files. We'll use the files in the resources folder. Let's add a sequence to the designer panel, rename it, and add an annotation. Next, we'll add an attach window activity and indicate our Notepad file. We'll also change the name of the activity to follow best practices. Now, to remove the double spaces in the text file, we'll use the replace command, whose shortcut is Ctrl-H. We can automate this action in Studio by using the send hotkey activity. For the next step, the robot must fill in the fields in the replace pop-up window, so we'll add 2 type into activities. Since we need to find all the double spaces, the string we will enter in the find what field consists of 2 spaces, which must be placed between quotation marks. The second type into activity will instruct our robot to enter a single space in the replace with field. And now we can move on to a click activity to select the Replace All button. After performing these steps, we can close the pop-up window using one more click activity. Let's save the workflow and run the project to see how the execution goes. It works! But what if we want to remove the double spaces in a different file? Let's try that out. We'll simply close this file and open a different one and run the workflow again. This time, the UI element corresponding to the selector was not found. Let's take a closer look at the selectors to see what's wrong and try to repair them. We can notice that the title attribute contains the name of the previous file. Let's click the Repair button and select the new Notepad file. If we look at the selector now, we can see that the first 2 characters in the title were replaced by an asterisk. This illustrates the use of selectors with wildcards. An asterisk replaces 0 or multiple characters, while a question mark replaces precisely 1 character. Let's run the project again. And it's executed successfully this time. Now let's see what happens when we open the third file, which is an entirely different timestamp in the name. The title of the previous 2 files was similar, and the selector wildcard only replaced the 2 characters that differed from one file to the other. As a result, the value of the selector attribute still contains a part of the file timestamp. Let's open the selector editor menu to make some adjustments. Instead of clicking repair, as we did before, we can edit the attribute manually. In this case, we can remove the timestamp altogether and replace this entire part of the file name with the asterisk. The selector is valid, so let's click OK and run the workflow. It worked. Key takeaways for this part of the lesson. When working with a series of files or pages, selectors may need to be fine-tuned to apply to each individual item in the series. Using wildcards is a great way to achieve this. You can add wildcards automatically by clicking Repair or manually by editing the selector. The available wildcards are the asterisk and the question mark. An asterisk replaces 0 or multiple characters, while a question mark replaces just one.
A few moments later.
In this next part of the video, we'll focus on generating dynamic selectors using variables to correctly identify the UI elements in an application. We'll consider a scenario where our robot will collect the data from an Excel file and then enter it into the UI demo application. For each entry, the robot must select one of the 3 radio buttons, depending on the value in the used cache count column. We already have a blank process created. The first part of the process consists of reading the information in the Excel file. To do so, let's add a read range activity. What will a range activity do in our situation? It reads value from our Excel file into a data table. Coming back, we'll browse for the file and clear the range field to read the entire sheet. Let's store the collected data in a variable called input data with a prefix dt in the data table field. The second part of the process is to enter the data stored in the data table into the UI demo application. So we'll use an attach window activity and indicate the UI demo application. Since we want to repeat a series of operations for each processed row in the data table, our next step is to add a for each row activity. Here we'll use current row variable as an iterator that reads each row from our data table dt input data. And to be able to select one of the 3 radio buttons, we must enable the use cache count option. So we'll add a check activity and indicate use cache count checkbox. Next, the robot needs to select the radio button based on the value indicated in the spreadsheet. Can you recall the activity that helps to set values to variables? Yep, you're right. We'll use the assign activity. In the to field, we'll create a new variable called count option by pressing Ctrl K. This variable stores the value of the radio button that we need to select. In the value field, let's add an expression that extracts the value from a data table cell that belongs to use cache count column and converts the value to string. So we just retrieved the value of the radio button that we need to select. Now let's select the radio button using one more check activity and indicate one of the items, say use amount from the use cache count section. Now let's look at the selector and adjust some attributes to make sure that any of the 3 radio buttons can be checked at runtime, depending on the value extracted from the data table cell. The name attribute indicates a specific radio button. It's also the only attribute whose value must change to point to one of the other 2 buttons. To verify that the correct option gets checked at runtime, we can replace the hard-coded attribute value with the count option variable. At runtime, the variable will hold the correct value for each iteration. To use the variable, select the use amount text, right-click, and choose use variable. We'll choose the count option from the drop-down for the variable name field. Click confirm to use the variable and OK to save the changes. This method is called nicer variable support. Now that we've set the name attribute value to a variable, our selector is dynamic. As a result, it can uniquely identify a UI element at runtime according to the value of the variable. The third part of the process is that we need to type the values into the 3 fields cache in, honest check, and not honest check, and then click accept. Let's add the first type into activity for the cache in field. In the text field of this activity, we'll enter the expression to retrieve the value from the cache in column and convert it to string. Next, we'll indicate the cache in element. Now let's repeat the steps for the second and third type into activities. The only difference being that we're indicating the on us check and not on us check fields, and we're getting the data from their respective columns. The last part of the process is to click the accept button. So let's add a click activity and indicate the button. Before running the workflow, let's remember some of the best practices related to studio projects. Whenever the application allows it, use simulate click or type. Let's now check this option for all our UI automation input activities. We'll also rename the activities. Let's make sure to close the Excel file and deselect the checkbox in the UI demo application. Let's run our workflow. The values in the three fields and the selected checkbox are changing. And that's done. A quick recap here. We created a selector here that contains a variable, namely count option, which stores a value extracted from an Excel file and enables the selection of the corresponding checkbox. Now, try to identify other use cases where variables can be used to make the selectors correctly recognize UI elements.
A few moments later.
In this next part of the video, we will learn about index variables and how and when to use them in selectors. Now we'll build a web automation project that extracts data from the Acme website. Let's have a look at the data in Acme. We don't need the entire table. Instead, we only want to read each individual number in the work item ID column. We'll start this new project by adding a sequence to the designer panel. We'll change the name and add a description to make sure that the purpose of the workflow is clear from the very beginning. Obtaining the work item IDs from the Acme webpage. The selectors that we generated in the previous parts of the video were partial because we used the attach window activity. Now we'll continue working with partial selectors, but we'll use attach browser instead. Let's indicate the browser window. We want to avoid using the screen scraping wizard to obtain the information in the table. So we'll use a get text activity. We can indicate any item in the work item ID column, say this one. Let's have a look at the generated selector by clicking edit selector. Let's take note of the table column and the table row attributes and their values. Let's see the selector in UI Explorer. If we click indicate on screen again, but we select a different ID like this one, like the first one, we can see that the value of the row attribute changes and becomes 2. If we point to the last element in the list, the value changes once again. For now, we'll save the selector as it is. In the next steps, we want to loop through the work item ID UI elements by using an int variable to change the value of the table row attribute. Let's create a new variable of integer type called index. As we've seen, the first cell that holds the work item ID contains a table row attribute with the value 2. So we can set a default value of 2 for our variable. Let's open the selector editor again to replace the value of the table row attribute with our variable. We'll select the table row input field and hit Ctrl plus space, which enables us to select the variable. Let's click OK. Now we've created a dynamic selector that has a default value. Next, we'll add a while loop inside the attach browser activity. There are 12 rows in our table, so let's type the condition index is less than 12. Let's drag the getText activity and drop it in the body section. We'll create a variable to store the output for each item. Let's call it text. Next, we'll write the work item ID value to the output panel using a log message activity. The message is work item ID followed by a colon, a space, and a text variable. Last but not least, let's make sure that the value of the index variable increases after each iteration. We'll use an assign activity and type index +1 in the value field. Let's save and run the workflow. The output panel now contains all the work item IDs, so the dynamic selector that we created earlier is working perfectly. To summarize, in this part of the video, we've explored how, when the situation requires it, we can use a variable of integer type in a selector to iterate through a series of UI elements.
2,000 years later.
In this part of the video, we're going to talk about managing difficult situations in which reliable selectors aren't automatically identified in the studio. We'll learn how to use the anchor base, the relative selector, the visual tree hierarchy, and the find children methods to improve the reliability of a selector. Selectors are one of the core features of UiPath Studio, and it may be a bit challenging to understand at first. One of the difficulties is that the selectors must be specific and generic at the same time. To be precise, selectors should be specific enough to uniquely identify interface elements, but also generic enough to work even if there are a few changes on the screen or if there are a series of items being processed. So let's consider a use case. Here, the position of the input field changes every time we click the Submit button. To demonstrate this, we'll use the RPA Challenge website. Let's begin. We already have a simple workflow created. Let's also ensure that we have the RPA Challenge website opened in the Edge browser. The purpose of our main.xaml workflow is to highlight the first name text box on the RPA Challenge webpage. You check that our selector is reliable, the robot will loop through, highlighting the text box and clicking Submit 5 times. It uses the index variable to keep the count. So how can we start assessing the reliability of our selector? We'll open UI Explorer and indicate the first name field from the RPA Challenge website. The selector generated by this activity uses a tag and ID to identify the element. The clue that the generated selector might not be good enough is that it contains an ID attribute. This ID is a random string of characters and is dynamically generated, so it changes every time the web page is refreshed. We can tackle this problem in different ways. Let's have a look at a few of these approaches. We'll use the same example for all of our approaches. The first approach is the anchor base. We've created a separate workflow file for this, anchorbase.xaml. Let's open it. It's important to understand how this works. Anchorbase uses a stable element, let's say a field label, to perform an operation on a less stable related element. In this example, the less stable element is the first name text field. The anchor sets a starting point on the screen and looks for a match in a specified direction. Let's add an anchor-based activity to the workflow. This activity supports 2 activities for the anchor section: find element and find image. For this example, we'll use the find element activity. This activity waits for a specified UI element to appear on the screen and returns the element as a UI element variable. Let's add it to the anchor section. Next, we'll indicate the first name label on the website as the anchor element. We'll drag a highlight activity inside the action section and indicate the first name text box. Let's save the project. Now to run the workflow, we'll invoke the anchorbase.saml from the main workflow and click Run File. Great. We can see that the workflow is executed as expected, even though the text fields change every time the page refreshes. This concludes the first approach, in which we use the find element activity as an anchor to stabilize the selector. Now let's look at the second approach. The relative selector approach, where we stabilize the selector using anchor selector from the UI Explorer. We begin by adding a highlight activity and indicating the first name text field on the RPA Challenge website. Now we'll edit the selector by going to the UI Explorer. Here we'll click Indicate Anchor and we'll select the first name label as an anchor element to our target. The selector that is generated isn't good enough. It still relies on a dynamic ID attribute to identify the target element. So we'll uncheck the ID option and validate the selector. Our selector is valid and ready to be used for the highlight activity. Let's save the changes. Okay, it's time to run our workflow. Let's save the workflow, invoke this from the main workflow, and click Run File. It works. And this concludes our second approach, in which we can improve the selector by creating a relative selector using UI Explorer. Now let's look at the third approach, called the visual tree method. In this method, we stabilize the selector by including the tags and attributes of an UI element that is above in the hierarchy. Let's open this workflow. As before, we'll begin by adding a highlight activity and indicating the first name text field. Now we'll edit the selector by going to the UI Explorer. This method required some analysis in the UI tree. We see that the input field is under a div container together with label. Under closer inspection of the div container, we notice that the first name label is present under the inner text attribute. This will enable us to construct a more reliable selector. Inside the div container, we'll select the input field where the entire UI tree is highlighted. Let's remove the ID attribute. Next, we need to activate our target attribute. To do this, we'll activate the parent node and enable the inner text attribute from the right-hand side. This results in generating a reliable selector for our activity. Let's validate and save it. Let's save the workflow, and we're done. We'll go back to main, invoke visualtree.saml, and run the project again. It works. This concludes our third approach, in which we can improve the selector by configuring a better path in the UI tree. So far, we've seen three methods in which we can improve a selector and find ways to identify the elements on the screen. In some rare cases, these three methods aren't enough, and we need to do something even more specific. So it's time to find out how we can use the activity called Find Children. This method works by using the Find Children activity to target a reliable container and return all the child UI elements of that container. To see it in action, let's open the Find Children SAML workflow. Let's also add a Find Children activity. Let's go to the UI Explorer, click Indicate Element, and select the first name text box. We'll click div container, which is a parent container to the UI element we want to target. We'll enable the inner text attribute from the right-hand side, validate, and highlight. We'll notice that it highlights both the first name label and first name text box. The selector looks stable. Let's copy it. We'll return to the UiPath Studio. For the Find Children activity, we'll indicate on screen the first name label just to replace the generated selector with the one we've copied earlier. The output of this activity is a collection of all of the UI element children that are identified inside the defined scope. We'll create a new variable called children to store the output of the activity, and we'll change the scope from find children to find descendants. This way, the activity will iterate through nested containers. If we were to have another container inside of the parent container and the input filled some levels deeper, we could still find it. With the find children scope, we would only get the top level. The children variable is a collection of UI elements. We'll iterate through it using the for each activity. We'll call the iterator element. The type argument will be UI element, and we'll set children as the input variable. When configuring the highlight activity, note that our input isn't a selector. What we have is an element from the children collection. To be clear, an object of UI element type referenced by the element iterator. This means that instead of using the selector property, we'll add the element iterator to the element property. For any given UI automation activity, the selector and element properties both cannot be filled in at the same time. Only one or the other can be used to identify an element. If we highlight all of the elements in the collection, we'll get both the first name label and the text box as well. To solve this, we'll use an if statement to identify the input field. We'll add an if statement activity and enter this expression here. Element.getFriendlyName.contains input. We'll move the highlight activity inside the then block. Let's save and run the project from the main by invoking the workflow. It works. This concludes our last approach in which we use the find children activity and return all of the child UI elements of that container. For a quick recap, in some situations, identifying an UI element reliably may require more advanced techniques. In this video, we've demonstrated the anchor base, relative selectors, visual tree, and find children methods. Anchor base uses a stable element to perform an operation on a less stable related element. Relative selectors work in an equivalent way and are generated by clicking Indicate Anchor in UI Explorer. The visual tree method entails analyzing the target element and the parent nodes in UI Explorer to identify a combination of attributes which makes the selector more reliable. And find children lets us indicate a stable container and retrieve its child UI elements as a collection. We can iterate through the result and filter for the element that we want. UI automation activity can either use a selector of type string in the selector property or an object of type UI element in the element property, but not both, to identify a target. Whenever you encounter a difficult situation, like using dynamic web pages where the reliable selectors cannot be identified automatically, think of all these possible approaches and apply the appropriate one. Let me know in the comments if you have encountered difficulties with selectors that have not been mentioned here. I would love to offer some advice, and I hope some of the techniques we went over today can help you. If you find this video helpful, you can get additional RPA learning resources just like this on the UiPath Academy. There's a course named Selectors in Studio, as well as 3 other selectors courses on there. I highly recommend checking them out. Thanks for watching. Subscribe to this channel for upcoming content on how to start or build a career in tech, how to automate using low-code RPA, how to build real-time low-code data pipelines, and other tech content.
Visit us at uipath.com to learn more.